We'll look at page 251 and talking about scientific notation. So I'm using the example of 6.02 times 10 to the 23 molecules. This is the most famous number in chemistry. It's known as Avogadro's number. And its symbol is capital N with a subscript of A. Like Avogadro's number, all numbers written in scientific notation have three different parts. So all the digits, like 6.02, that are to the left of the times 10, these are referred to as the coefficient. And the coefficient must be written in a range. And the range, the value or the coefficient range, it must be at least 1 or greater, so 1 or greater, but it must also be worth less than 10. So basically the range runs anywhere from 1 to 9.9999 to infinity. Okay, so as long as the coefficient's range is less than 10. The scientific notation also has this base, so the times 10 is the base, and the base is powers of 10, and this represents our decimal positions, because every time you move the decimal point, you are changing the value of the number by a factor of 10, making it 10 times greater or 1/10 compared to what it was before. And then lastly, probably one of the more important parts of the number is the exponent. And the exponent, it really conveys or maintains the value of the number. What it does is it maintains the value so that we don't have to write out all the placeholders. So that exponent is the value. It represents all the placeholders. So for example, if I was to take 6.02 times 10 to the 23rd and just write it all out with all the digits showing and showing its value, the 23 means I have 23 decimal moves. So I can move this decimal 23 times, and because this is a positive exponent, it wants me to move the decimal 23 positions to the right because it's positive. So my first two moves would be moving it around the 0 and the 2. So I could write it as 602. Once when I've moved it around that 0 and the 2 and the coefficient, I've used up 2 of the 23 moves. Now I have 21 more. So all of those other moves, I would put in a 0. So I would have to add 21 zeros to write this out in decimal form. So that's 9, 12, 15, 18, 21. So Avogadro's number has all of these 21 zeros trailing the 602. So it's a huge, huge number. It's much easier to write it as 6.02 times 10 to the 23rd power.